So thank you to everybody for joining today's Linux Foundation Decentralized Trust virtual meetup. We are talking about transferring assets between networks with Hyperledger Cacti, and we have Jennifer Bell today, who is the speaker. So Jennifer, please.
Well, thank you very much. Okay, let's get going. So a quick overview of what I'm going to cover in this talk. It's going to be start off with the short overview of the Hyperledger Cacti project, just to get you oriented on what's available for you to start using in that project. And it's a little bit special because it's two projects in the same code base. So I'll be talking a little bit about those two different projects and their different approaches. I'll go through some blockchain interoperability scenarios that you can use Hyperledger Cacti for, including sharing data, transferring an asset, and exchanging assets. And I'll talk about my window and how I got into this, which was the Common Operator Primitive Module Mentorship Project with the Hyperledger Foundation. Now, the point of this talk is that it's really a very high level. So it's I'm going to use some pretty simple language, and most of the time not being very techy, so that if you don't have a strong background in the domain area, I hope you can still follow along. So a little bit about me. I have a background in data networks, particularly in startups. I had at one time an open government nonprofit, but more recently I've been working in biotech. The last 15 years I've been a product manager, and before that I had some roles as a software architect. So how I got into this was I was looking around for something interesting to do, and I saw the Hyperledger mentorship. So I thought, well, that sounds really neat. And so I was lucky enough to be selected for the Common Operator Primitive Module for the Hyperledger Cacti project. So what the COPM primitives is they're reusable commands for blockchain interoperability. The goals for the project were to implement primitives for the Cacti Weaver project. Now, they already had an SDK for their system. It was already sitting there. They had SDKs in Go and in JavaScript, but my job was to make a gRPC command interface so that these primitives could be triggered remotely by a client in any language. And also we wanted to make it easy to support new ledger types. So I created a generic testing framework to support that. We wanted to make it easy to contribute to Cacti Weaver. So one of the things that I did was I added some scripts to automate test network setup. And in general, we wanted to promote Cacti in the open source community. So a brief overview of the Hyperledger Cacti project to get you oriented. And before I get going, I've got some slides that are comparing the two projects, and I want to make it clear that they're talking about the Cactus Classic. So what Cactus was like when I first started working on it. There's an upcoming secure asset transfer protocol implementation, which has been the focus of Cactus developers for the last 18 months. It's a gateway transfer protocol, but it's not yet complete. So it's not going to be the focus of this presentation. So you should watch the Hyperledger Cacti space for more announcements. And I'll talk a little bit about it later. So getting back to what's there in the project now that's sitting there and waiting for you to pick up is the Cactus project and the Weaver project, both in the Hyperledger Cacti repository. So they're really quite different, and they follow different paradigms. So Cactus project is a centralized system coordinated by an API server. It started off from Accenture and Fujitsu. The ledgers that are implemented, it has Hyperledger Fabric, Corda, Bezu, Stella, and some others. And one thing that's nice is that it has a really strong open source participation. Weaver is a decentralized paradigm. It has per network relays. It comes from IBM, particularly the work of Rama Venkatraman and Sandeep Nishad. It's got two ledgers implemented fully, the Hyperledger Fabric and Corda. Bezu has just started. And the open source participation in comparison to Cactus is really just getting started. In some real world applications, of the two systems. For Cactus, there's a proof of concept of a cross-border security settlement launched by Asian Development Bank. And there's the Hyperledger Cactus Climate Action and Accounting Special Interest Group are using the Fabric and Bezu quorum connectors. For Weaver, there's a proof of concept for the Banque de France and HSBC. There's a central bank digital currency application for the Digital Euro Initiative. And was also a delivery versus payment atomic swap between Casper Labs and Fabric Networks that was demonstrated at the blockchain hub in Davis in 2022. So if you were to zoom out and a really high level overview to get a picture of how the two systems are side by side. On the left, there's Cactus. Again, this is Cactus Classic, where you have the API server that is coordinating between two ledgers. Whereas on the Weaver side, we have one relay per network, and the relays manage the coordination. Thinking about it at a system design, the Cactus philosophy is an open philosophy. There's a server plugin framework. There's, unlike Weaver, there is no footprint in the smart contract. And everything that you want to do in the system is set up in your custom application. Whereas the Weaver system is more of a structured guardrails approach, in that you can take a number of things and just reuse them directly as they are. So you can reuse the relays, you can reuse the interop contracts. And what you do is you customize an asset adapter for the assets that you want to move around. Just to drive this point home, there is this smart contract footprint. There's this interop contract that defines the operations and enforces your access. And then you add to that your custom asset adapter contracts. And this interop contract works with some custom data structures that are stored in the ledger. So your access rules and your verification policies are set up as data structures. So in a lot of ways, the ways that you can use the system are pre-thought, which is kind of an advantage. So going back to our side-by-side diagram at a really high level, what's the difference between what's framework and what's custom? The Cactus the framework gives you some plugins, and you're responsible for the API server. Whereas in Weaver, the relay and the interop contracts come out of the box, and you make an asset adapter. So to deploy a system, if you're going to spin one up, so what you would do for Cactus is you would pull in your desired plugins and your asset adapters, your keychain memory, and then you would write your custom application and get it out there. Whereas Weaver, what you want to do is write and deploy your asset adapter contracts, and then deploy your interop contracts, your relays, and populate your access rules, which you can trigger. Once that's all set up, you can trigger it using the SDK or the gRPC command protocol. When you want to, you've got something set up and you want to build on it, like for instance, you want to expose a new type of asset for trade or add a new bank to your network of banks. For Cactus, you would probably need to go back and do some modification to your custom application, depending on how you've set it up. Whereas because you've got this more modular design with the Weaver, you are really for exposing a new asset type, you would just be adding a new asset adapter contract and populating the asset rules. And if you want to trade with someone else, all you need to do is populate some access rules for them. So the strengths of the different systems is that Cactus, the learning curve is quite low. It's a very easy system to understand. And there's lots of examples for you to take and work from. But then the ease of change is low, because anything else that you want to do, you have to probably go back and modify your custom application. And for Weaver, while you've got this higher upfront investment that you need to learn the project structure and the guardrails that are there, once you've got it figured out, you can easily adapt. So you can repeat the existing patterns, and it's very nice that the networks are completely independent. So the two systems, in my opinion, are best. So because you've got this central server, for Cactus, it's really everybody has to trust that all the software on that server is working correctly. And so just that is going to limit it to just a few participants. And that's not really a technical limitation. It's more of a human limitation. And so it's best for a more stable environment. And whereas a Weaver, because the networks are all completely independent, you don't really need to trust anyone. You can have as many, and you can scale to as many participants as you like. So it's more suited for a changeable environment. Okay, so getting back to my particular window on this, which is the Cacti Common Operators module, we'll look at three scenarios for interoperability. So this was the command interface that was implemented for the Cacti Weaver. So really, we're just totally focused on the right side of the charts here, where there is a Corda implementation and a Hyperledger Fabric implementation. So the primitives that are available for interoperability are data sharing, asset transfer, and asset exchange. And according to Rama Venkatraman, who spent years researching this area, these are really the full set of things that you might want to do between two different networks. So let's take a look at how we can use Weaver to achieve them. So data sharing is, in short, the ability to read data on another network. And it's an important point that to do this in the Weaver system, the other network must first give you permission. And the primitive that we use to do this is called getVerifiedState. So the data sharing flow diagram, Alice wants to get verified state for X on ledger B. So she sends that command to the COPM gRPC on network A, which then goes and sends a message to the relay for that network to read state X on ledger B. That gets forwarded to relay B, and who reads state X on ledger B. And so within the interop contract, the system checks the permissions of that system and reads the state, returning it signed back to the relay, which returns it back to the relay for the right network, returning it back to the command server, who then goes and uses the ledger to verify the signature. And once that signature is verified, that data is checked and returned to Alice. That flow that we just saw comes up in asset transfer. This is where an asset changes networks. So an asset is burnt on ledger A and then minted on ledger B. And the Weaver system, to do this, introduces two ledger data types. A pledge, where the record is created on ledger A, when the asset is burnt, and that contains the details about the asset and who it's promised to. And a claim, which is the corresponding record that's created when the asset is minted on ledger B. So the two primitives for this are pledge and claim pledge. And if we want to look at the flow, so Alice and Bob agree to trade or to transfer an asset. So Alice pledges the asset on her system, which creates a pledge and burns the asset. Now, these two actions are atomic, so they either both happen or they both don't happen. So if the pledge is created, that means the asset is burnt on system A. So Alice or some other external system communicates to Bob that the asset can be claimed. So Bob can call the claim pledge primitive, which will go and trigger a cross-network data sharing flow to read the pledge on system A and sign it, so that when that's verified, the system B can create the claim data structure and mint the asset. And again, these actions are atomic, so they either both occur or they both don't occur. The third type of scenario is an asset exchange, which is probably better thought of as a swap. Because in this scenario, the assets stay where they are, two-party swap ownership of the assets. So they can be on different networks, And in Weaver, the system uses hash time lock contracts to accomplish this. And for this scenario, both parties should have visibility of both assets in both networks. So we don't really use any internet or communication in this scenario, so no relays. The primitives that are used are called lock and claim lock. So Alice and Bob agree to trade the tokens for a bond. And so Alice goes and locks her tokens, and Bob locks his bond. They tell each other how they've locked it and the secret, and they can both view the network to see that that's actually happened. Then they can use the claim lock, give it the given secret, and the system will verify the lock. And then if it's verified, change the bond owner to Alice. And then when Bob claims his tokens, verifies the lock and changes the token owner to Bob. So that's an exchange where two users just swap ownership of two different assets. Getting back to mentioning secure asset transfer protocol, this is something that the Cactus team is working on. It's an upcoming IETF standard. It's a multi-stage negotiation with additional messaging. So in this scenario, just to mention this tangentially, Cactus in this scenario would work more like a gateway, so you would have one gateway per network. So, and then it would be a multi-stage negotiation with additional messaging that's based on distributed database transaction patterns and with a two-phase commit. So the negotiation is done by the network gateways, and it adds a database for logs for resolving disputes in case of crashes. So in some ways, I think there's a little bit of a naming problem because the secure is a really loaded word. So by calling it secure, it throws some implicit shade on other solutions that they're maybe not secure. And I don't think that that's necessarily the case. Like if we go back to asset transfer, the main thing that I think you want to be guarding against is the risk of a double spend. And if these two things are atomic, then you don't need to worry about that. So really, it doesn't necessarily mean that other ways of doing things are insecure per se. Okay, so let's get back to the COPM module and what I was specifically working on. So we wanted to implement the gRPC commands for Weaver, so these can be triggered remotely by a client in any language. We made that, like I mentioned, a generic testing framework to make it easier to support new ledger types. And we automated test network setup to make it easier to contribute to Cacti Weaver. And that was actually a big deal because this was the first time that somebody that didn't work for IBM was able to set up a Cacti Weaver network with a script. And we also wanted to promote Cacti in the open source community. So let's look at the first goal of the gRPC commands. Those are available. Let's see if I can click it. Yeah, okay. So the COPM module followed the nice pattern that was established by the other Cactus packages in that the gRPC, it's kind of atypical to do this, but the gRPC was first defined as an open API definition. And because of that, we get to pull in a whole bunch of nice documentation standards like this open API documentation. So you can click on the individual primitives and then click around to look at their definitions. Then creating a generic testing framework was done as a GitHub matrix test job with all of the available combinations. So we've got fabric to fabric, fabric to Corda, Corda to fabric, and Corda to Corda. And there's, like I mentioned, the automated test network setup. So there's a one-step command to deploy a test network for either the Corda or the fabric implementations. And the last goal was to promote Cacti in the open source community. And so I want to thank you for coming to my talk. So I can open it up to any questions.
Yes, sorry, I don't find how to raise my hand, so I just speak. About the pledging, is there a risk if you pledge and you burn it and it's not claimed that it's gone?
So that's a great question. So the Weaver system allows you to reclaim or to remint your asset if the uh, uh, pledge isn't claimed. There is a way to go back and undo the burn.
Okay, thank you.
Yes, Rama?
Hi. Jennifer, thanks. That was a great presentation. Just want to clarify one thing. You mentioned the SATP effort that's been going on. So there are actually two SATP implementations within Cacti right now. One of them is, as you rightly point out, is the Hermes implementation that the Cactus that's happening, the Cactus part of it. There's also a year before you, there was an intern who was trying to do to a SAP implementation using Weaver relays as well. So there is one such implementation within Cacti. The thing is, it's not a very mature implementation. It's just a sample implementation. So, since we are here in an open forum, if anybody wants to help refine that, make it a more generic, reusable protocol, happy to solicit your contribution. Anyway, thanks. Great presentation, Jennifer.
Well, it seems like we don't have any more questions. And I'd just like to, when I wrap up, I'd like to thank my mentors who, a couple of them are here today. So thank you very much, Rama, and thank you, Peter.
You're welcome, Jennifer. You did a great job.
Okay, so at the end of my presentation, David is going to send out is going to send out the deck, and there's some handy resources on the very last slide if you're looking for more information. So thank you for coming today. Have a good rest of your day.
Thanks.
Great.
Bye.
Thanks, Jennifer. Thanks, everyone.
Bye.
Thank you.